I think the danger of AI is much greater than the danger of nuclear warheads, by a lot, mark my words. AI is far more dangerous than nukes. Ever wondered what might happen if we brought together two revolutionary technologies, AI and quantum computers? Recently the U.S. government stumbled on something unsettling and has taken an intriguing step, urging Google and NASA to halt their quantum computer development efforts. This is something that renowned physicist Michio Kaku has been warning about for years. What's going to happen? Join us today as we uncover the truth about quantum computers and AI. So the two of them, the chatbots that are revolution in software, and then quantum computers, which are revolution in hardware when they get together, watch out. So we're talking about an extremely powerful alliance between software and hardware. Quantum computers are highly fascinating machines that operate based on the principles of quantum mechanics. Unlike our familiar traditional computers, which use bits to represent information as zeros or ones, quantum computers work with qubits. Now these qubits are a whole different ball game. They can hold information as both 0 and 1 at the same time, thanks to a wild phenomenon called superposition. Qubits are the rock stars of the quantum computer world. They can exist in multiple states simultaneously, all thanks to their superposition powers. This means that quantum computers can crunch through complex calculations in parallel, potentially speeding things up exponentially compared to our classical computers. But wait, there's more. Entanglement is another mind-blowing trick of the quantum computer sleeve. It's like magic that connects multiple qubits together. When entangled, the state of one qubit becomes intimately linked to the state of another no matter how far apart they are. It's like they have a cosmic connection. So quantum computers aren't your run-of-the-mill machines. They harness the extraordinary abilities of qubits to compute things in an entirely different league. Traditional computers use classical bits and can only go one step at a time, either 0 or 1. But quantum computers tap into the superposition and entanglement phenomena to process oodles of information all at once. Talk about multitasking on a galactic scale. Now, if you're wondering where this quantum revolution began, well, it all traces back to the early 20th century when the captivating quantum theory took its first breath. Since then, scientists have been on a thrilling endeavor to unlock the true potential of quantum computing. Quantum theory is like a wild adventure into the tiniest building blocks of our universe, atoms and subatomic particles. This branch of physics brought in a whole new perspective called quantum mechanics that turned classical physics upside down and inside out. Back in 1900, Max Planck took the stage with a radical idea. He proposed that energy is not a smooth and continuous flow, but rather comes in discrete little packets called quanta. Imagine energy as tiny energy snacks. This groundbreaking concept laid the groundwork for understanding that particles like electrons can only exist at specific energy levels, no in-between shenanigans. Then in 1925, Werner Heisenberg added to the quantum commotion with his famous uncertainty principle. It's like saying, hey, you can't have it all at once. According to Heisenberg, we can't pin down the exact position and momentum of a particle simultaneously. The quantum world loves its surprises, keeping us on our toes and embracing probabilities. In 1935, the plot thickened with Albert Einstein and his buddies Boris Podolsky and Nathan Rosen. They cooked up the EPR paradox, a thought experiment that would make your head spin. They raised the idea of spooky action at a distance, where entangled particles seem to communicate faster than the speed of light no matter how far apart they are. It's like quantum teleportation, and it gave us all a good dose of scientific goosebumps. But the party was just getting started. It wasn't until 1980 that the revolutionary concept of quantum computing popped up on the scene. We're talking about computers that harness the mystical powers of quantum mechanics to do some seriously mind-blowing calculations. In 1982, physicist Paul Benioff had a lightbulb moment. He envisioned a whole new breed of computers harnessing the incredible power of quantum mechanics. Yep, we're talking about quantum systems performing mind-blowing computational tasks, making our regular computers look like snails in comparison. But the quantum computing fever didn't stop there. In the same year, physicist Richard Feynman got all fired up and expanded on Benioff's ideas. He saw the potential of quantum computers to tackle problems that classical computers would just throw their hands up at and say, "No way, I can't deal with this." Feynman's visionary thinking ignited a bonfire of curiosity in the scientific community, laying the groundwork for further exploration and research in the field of quantum computing. Throughout the following decades, researchers rolled up their sleeves and dug into the nitty-gritty of quantum mechanics, understanding the principles that underpin this technology. Then in 1994, the math wizard Peter Shor pulled a rabbit out of the quantum hat. He developed a groundbreaking algorithm that showcased the true potential of quantum computers. It's like he cracked a secret code allowing quantum computers to factor large numbers in a snap way faster than our classical computers could even dream of. The year 1998 brought us the first glimpse of a real practical quantum computer. A team of researchers at the Los Alamos National Laboratory crafted a 2-qubit quantum computer using fancy-sounding nuclear magnetic resonance techniques. Sure, it had its limitations, but it was a crucial milestone in the quantum computing journey. Forward to the early 2000s, the era of quantum computing progress. Multiple research groups and companies were on a mission to craft even more sophisticated quantum computers, and they did deliver some breakthroughs. In 2001, the IBM team hit the jackpot. They proudly presented the IBM Qubit, a 7-qubit quantum computer that left scientists and tech enthusiasts in awe. And then the quantum community got busy with something called quantum error correction. You see, qubits can be a little fickle. They interact with their environment and can lose their quantum charm, so researchers put their thinking caps on and came up with clever codes like the surface code to protect quantum information. It was like giving qubits a sturdy quantum armor, making quantum computers more reliable and robust. Fast forward to 2005, and researchers at the University of Innsbruck and the National Institute of Standards and Technology (NIST) achieved a remarkable feat. They assembled a working quantum computer with 5 qubits. Now you might think, only 5 qubits, what's the big deal? But trust me, it was a quantum leap. This small yet mighty machine proved that practical quantum computers were within our reach. The quantum train didn't stop there. In 2007, scientists at Yale University cracked the code to create stable qubits using solid-state systems, materials that are more stable and easier to handle. It was like finding a new recipe for quantum stability and paving the way for more user-friendly quantum computers. In 2010, the University of Science and Technology of China pulled off something straight out of sci-fi. Quantum teleportation. No, not beaming people around, but teleporting the quantum state of one particle to another particle far away, 10 miles to be precise. This was epic because it showcased the potential for building quantum networks where quantum information could travel great distances, like a quantum postman doing its rounds. In the year 2013, a powerful collaboration between Google and NASA took shape. They teamed up to develop a groundbreaking quantum computer named the D-Wave 2. The plan was to set up this cutting-edge technology at NASA's Ames Research Center and let it tackle complex optimization problems. This partnership was a game-changer and gave a major boost to the field of quantum computing. But the quantum community wasn't stopping there. In 2016, Google took the quantum world by storm with its 9-qubit chip named Sycamore. This was a giant leap towards building a practical quantum computer that could tackle problems far beyond the reach of classical computers. Google went all in and declared quantum supremacy, a milestone that sent ripples of excitement through the scientific community. It was like planting a flag on the peak of Mount Quantum and shouting, "We did it." So where are we now with quantum computing? Well, the journey is far from over, but we're making steady progress. Quantum computers have come a long way from their humble beginnings. They're still not perfect, they're prone to errors, and still have a long way to go before they become mainstream. But the excitement and potential are undeniable. The fusion of quantum computing with AI promises to unlock a whole new realm of possibilities. Imagine quantum computers taking a quantum leap in AI, revolutionizing everything from drug discovery to climate modeling and even cracking the secrets of the universe. But as with any revolutionary technology, there are risks and challenges that come along for the ride. Quantum computers could potentially break our current encryption schemes, putting sensitive information at risk. And then there's the fear of AI and quantum computers joining forces in some sort of doomsday scenario. Michio Kaku has been sounding the alarm bells, warning about the dangers of AI and quantum computers going rogue. Imagine a super-intelligent AI running on a quantum computer with the power to outsmart humanity. It's like a scene straight out of a sci-fi thriller. So while quantum computing holds incredible promise, we must tread carefully, ensuring that the benefits outweigh the risks. It's a thrilling yet challenging journey into the quantum frontier, and the possibilities are truly out of this world. So what's the bottom line? Quantum computing is not just a pipe dream, it's a reality in the making, and the fusion of quantum computing with AI is poised to revolutionize the world as we know it. But we must proceed with caution, navigating the risks and challenges that come with this cutting-edge technology. The quantum revolution has only just begun, and the best is yet to come.